Tired though.
You can only hide so much.
I can understand. I can understand. All right. Awesome. Awesome. Let me just greet more person. Hi, Bolo Atife.
Hello, good evening.
Good evening. How are you doing? How was work?
Work was great. Thank you. Thank you so much. I hope you had a good day too.
It was not bad. It was not bad. Thank you for
Nice.
asking.
Nice.
Welcome to today's webinar. Hi, everyone.
Thank you.
Welcome. 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 I think we can take one more person. Okay, our facilitator is not here yet, so we can still go around. I Asalim. I'm not sure if I pronounced your name correctly.
Anselm, good evening.
Ansalim. Awesome, awesome. Good evening. How are you doing today and how was work?
Stressful, but thank God today's over. Yeah.
Right, so thank God today is over and the weekend is upon us soon. So we're really excited. All right, thank you for joining. Let me take one more person that I've not spoken to today. Hi, Farida. Hi, Farida. Can you hear me? Farah. Sorry, I said Farida. Can you hear me?
Hi. Yeah, I can hear you.
Hi, good evening. How are you doing
Good
today and how
evening.
was work?
I'm fine. How are you too? Work was alright.
I'm fine. Work was all right. Awesome. I've actually missed your gist on the check-in calls, but then I look forward to catching up on the next one. It's good to
No
have you on the call
wahala.
today. Yeah.
Thanks, Jerry.
Yeah. Hello, everyone. Welcome to today's webinar. Today's webinar is anchored and hosted by Trefford, and it's so good to have everyone. By night 7:05, we'll be starting. So just go around to see as more people how they are doing. We have our facilitator here already, and we just get right into it. So we don't waste too much of our time. Hi, Sumto Chiku. Hi, Sumto. Can you hear me?
Yes, I can hear you. Hi, good evening, everyone.
Hi, good evening. How are you doing? And how was work today?
I'm fine. Work was okay. And yours?
It was good. It was good. Thank you for asking. Yeah.
Okay.
So I would just ask one person what they look forward to today in today's session. They will get right into it. So, hi, Rita. Can you hear me?
Hi.
Hi. How are you doing? And how was work today?
Hi. Thank you very much. Work is fine. It's still ongoing.
It's still on good. Oh, wow. Anyways, I hope you're able to wrap up work pretty soon. So I just want to ask you, what do you look
Yeah.
forward to in today's session before we get right into it?
Well, I'm hoping to have full understanding of how microservice work, like the whole architecture.
Mm-hmm.
So I'm really hopeful for that. That hopefully that will be able to cover all of those things.
All right. Also, I'm sure our tutor facilitator is ready for that. So I'll ask one more person, then we'll start. Hi, Josephine. Can you hear me?
Yes, I can. Hi.
Hi, good evening. So what do you look forward to in today's session?
Yes, just about the
Hello? Hi, Josephine. Can you hear me?
Yes, I can. Yes, I can.
Okay, I
I
lost you
answered.
for a
I
bit.
said,
Okay.
okay, yes. So I want to understand how microservices work and just to have that knowledge as a product manager.
All right, all right, awesome, awesome. All right, everyone. Good evening, everyone. Once again, my name is Esther, and I'll be your moderator for today, partially, like I said. So this session is anchored by Trefford. And Treford is an edtech startup with a primary focus on providing professional and business worldwide with necessary no-code tech skills to develop and expand digital products. And I have here with me Favor, who would be moderating alongside me. Hi, Favor, can you hear me?
Hi, Esther. Good evening to you. I can hear you loud and clear. Can
All
you
right, you
hear
have the
me?
floor. Yes, I can hear you. You have the floor, please.
All right. Good evening to the very beautiful people in the community of PIP. Although I cannot see your faces, but I can see some images and they look really good. Good evening to everyone. My name is Favor, Programs Manager at Treford. I see some familiar names that I know, and I see some names that I'm seeing for the first time. For those names I know, hi guys, how you doing? Good to see you here as well. And those people I don't know, how you all doing? How is work? Okay, you've been getting checking in about work. But quickly in the chat before as we get started, and we'll be introducing today's session. Last saying hi. Let's know in the chat just one or two things you're looking forward to in today's session as we get started in today's session. Just one or two things you would like to learn in today's session. Just let us have it in the chat. While I introduce our facilitator for today. Just like it has been rightly said, the session today is going to be on microservices and software architecture for product managers as we are in the month of, as we're in the quarter of learning about technical fluency. Okay, so today we have with us Ayatollah Salako, a facilitator at Treford, and he's going to be sharing, is a DevOps engineer with years of experience across multiple startups. But he said I should not do too much, so I won't do too much. So currently he's a sales engineer at OKI, and he's here to share with us today. Without any further ado, I'd like to pass the mic to Haya today. Haya today, how are you doing today? Thank you for sharing, Rita. I see you in the chat. How are you doing today, Haya today? And are you ready for us?
Good evening, everyone. It's good to be here, and thank you for the opportunity.
Yeah, good day, Ayatollah. All right, over to you, Ayatollah. Let's have it.
Okay.
You can share some get started.
Okay. So before we dive into it, I'd like that you know me better. Like Favor said, I was a DevOps engineer. Actually, I'm no longer a DevOps engineer, but my career has spanned design, that's graphic design, then product design, product ownership, product management, business development. Then I did technical product management, and then I'm currently a sales engineer at OKI, a digital address verification firm where we put 1 billion people on the map. And yes, I'm helping with sales efforts there, and then also integration efforts by our customers. So that's what I do today. And on the side, I also do some farming and some consulting as well. So I want to get us to know us as well, but I heard we have just 1 hour, so I may not be asking us to introduce ourselves personally, but I think I can get to know us better on a professional level. I think I can see some names I know I'm familiar with here. So about 3 or 4 people. You know yourselves. Good to see you here. And so briefly, let's quickly in the chat, if we have any technical knowledge before now, you can type 1 in the comment section. If you have no technical knowledge, apart from being a program manager, you can type 0 in the comment section. So I'll be looking through, and hopefully I get feedback from everybody or majority. Paula, we talk later. We talk about that during questions. Okay. I think there's a lot I think it's equal actually. So please engage in the comment section. If you have any technical knowledge before now, let me know. I think the zeros are more than one right now. Yeah. I think the zeros are more than one. Okay. We have about 50 people here. Oh, 36 people here. If I remove Favor and who else is that? I think Esther. That will be 36 now. There are 38 people. That will be 35 people. And I think under 15 people have, engaged so far. So please kindly engage. I would have sent you a link to a survey, but I thought maybe this would help with engagement. I would know the people who are actually here and those who are not. So we have 2 more minutes. It's 7:12 already. Okay, I think we can move on. Hopefully you guys can ask questions and can give me an idea of where everybody is at. But yeah, I think we can get started. So I'm going to share my screen now. And where are you? I would favor, please, after the call, I don't know if there's a way to reach out to everybody in the audience. Could you share the link to the video on API product management or API for product managers? I think it's a foundation. I honestly forgot. Should have reminded you to help share that ahead of the call. So I think that will help them to, have, for those who are not technical, have some foundations when it comes to API because they should build on top of that. Do you get that?
Yes, I got that. Definitely.
Okay. Yeah, cool. So let me share that. Let me expand. Yeah. Okay. So please, if you have any question, don't feel free to interject me. You can raise your hand, and then I'll pick you, and I'll ask you to speak. So feel free to interject. Let me know your thoughts. If you have questions, let's hear it. If you have suggestions or if you have clarifications, please, whatever it is, just make sure you are engaging me. Yes. So let's move on. We are looking at software and microservices. Yes, you will, but it won't be of much use to you. I intend to have a one-pager for you guys with references and links to, everything I've shared so far, and so that you can learn more after now. Because trust me, this is not all you need. This is just introducing you to what you need to be, to be on to improve your technical acuity, basically. So we're looking at software and microservices architecture for product managers. And we want to understand the role of microservices in product development. So I want to take about 40 minutes to run through this, and then the next 20 minutes to run through the rest of the course by, we looking into our browser. I mean, having access to my browser, and we looking at some practical use cases, basically. Let me share my entire screen so you can see instead of just one tab. Where are you? Okay, confirm if you can see my browser in details now. You can see my browser tabs and all of that. Yeah, cool. Okay, good. So let's look at why this matters to product managers at all. Why does software architecture, why do microservices, why do all of these things matter to product managers? Is it not just the job of the engineer and the DevOps engineers and the network administrators and the CTO, the list goes on. Why is the product manager involved? The truth is you'll find yourself in some settings where the product manager is expected to be technical, or some products will require the technical ability of the product manager. Not all products will, but some products will require it. And if you think you want to be in that, let me share my video so that you're not, sorry, apologies. Can you see me? Okay, cool. So, but not all products will require you to be technical. There will always be need for consumer PMs who understand the mind of the consumer, who are able to interface with them, who are able to build the right product for them. And then there also be need for technical PMs who not just build products that clients interface with, they also build products that clients don't get to interface with, but power what clients interface with, if you get what I mean. We'll dive into it. And one of the reasons I believe this subject or topic matters to PMs is that product teams work with microservices. It's widely acceptable. Most product teams or most products or most companies are going this route now. There are still very valid use cases for monolithic systems or architecture. Very valid use cases, but we are looking at microservices today. And the reason for that is because, again, it's widely used, it's widely accepted. The concept has come to stay. It has been around for a while as well. So you don't want to miss out on that. You want to understand how your product works in detail. Also, your decisions may also impact the architecture. Imagine your product is being served to about 3 million users, right? And you have a messaging system where your customers are supposed to get an email or a WhatsApp message or an SMS for every transaction. How do you want to do that? If you write your product requirement document or your business requirements, that requirement will inform your developers on what to do, how to make sure that at scale, over 3 million users receive the SMS they are meant to receive when they are meant to receive it. And even if it doesn't come in when they expect it, it should still come in regardless if it fails the first time, because they need that information. How do you want to do it? If you are building for 20 users, you won't need some robust technologies or systems. But imagine you are building for 3 million users. You will need an alternative. You will need not an alternative. You need a new approach or another method to serve them. So your product decisions also impact architecture. And then you need to be able to effectively collaborate with engineers. You need to be on their wavelengths. Maybe not every time, but most times and in most instances, it's best for you to be at their wavelength, because with that, you have influence. With that comes respect. With that comes value. With that comes influence. With that comes with that comes your ability to work with them well, seamlessly. You know, when you understand their lingo and even when you are able to challenge them on certain concepts, it makes it fun. It makes it more interesting for you and them as well, and the product. All right. Now let's look at what microservices are and what they are not. Microservices architecture is simply a software architecture where applications are built as small independent services, that communicate via APIs. The reason why I said Favor should share the link to the video on APIs for product managers is because we dealt with APIs in that particular video. We shared the details, the basics rather, of what APIs are basically. So please, if you can, do watch it when you have access to the link, or you can go to YouTube and search for API for product managers Treford on YouTube. You should be able to find it. My name should be there as well. I also just have or something. Yeah. So please go have a look. Now, like I mentioned earlier, there are small independent services communicating via APIs, and APIs have several protocols by which communication happens, but the most popular is HTTP, which is hypertext transfer protocol, and that's the communication model, especially for some type of APIs. Basically, you combine that with the fact that each of these services are not just services; they are not just there for being their sake. They are there to serve a specific function. If you have both, if you have an API with a specific function, if you have several APIs with specific functions, all of these come together to give you a product at the end of the day. That's why you have, for example, an e-commerce platform. You have an authentication service. You have an inventory service that takes care of your inventory or manages it. You have a checkout service. You have an order service or microservice or API, as the case may be. And then all of these come together. The customer authenticates, they check the inventory, they select their product they want to buy, they check out. They go to when they get to checkout, then they get to place an order, they make payments, and then logistics and all of that are taken care of as well. You have a whole comprehensive e-commerce system, right? Imagine a banking system. You have accounts, the user being able to sign up and sign in. Then you have payments, you have lending, the user borrows, the user pays or transfers and all of that, or buys their time. All of that. These are separate services. There's an account service, there's a payment service, there's a lending service, there's a KYC service that takes care of the customer's identification details, for you to be able to know them and offer them the right services. This gives you a whole banking system, right? So all of these services, they are built as separate entities. And as a matter of fact, they don't need to be built with the same programming language. They can be built with different programming language, but as long as the data structure, the structure of the data, your whatever service that is calling the API is intact, you'll get the right response, and the service works, right? If you look below, you'll see some icons. The first icon is what you call it's authentication. Basically, it's guarding the user, it's guarding the system. You have a messaging service, you have a function maybe for file compression or image compression. Then you have your database service. All of this will serve a function. So imagine a platform like Facebook. When you upload a picture to Instagram or Facebook or WhatsApp, something happens in the background. You just think WhatsApp minifies your image for minifying sake, or the fact that they just think they can. The reason is because it makes their own system more efficient. It saves them cost, storage costs, because all the files they're uploading to WhatsApp, Facebook, and Instagram, they have a size, and there's somewhere they are being stored with high availability, meaning that easily retrieve them with low latency. These servers come at a cost, and they also have a storage capacity, right? To make sure that storage capacity doesn't get maximized on time, they have to minify or reduce the file size that have been uploaded into their system, so that they can do that. That's why you see, if you upload a 15 megabytes picture or image or video to WhatsApp, you may end up seeing 5 MB by the time you are sending it, because a file compression has happened, and there's a microservice rather taking care of that file compression. The same applies to authentication. There's an authentication service that takes care of the user's login, user's access, what the user can access and what they cannot, and all of those things. Then there's a database service, of course, that takes care of all the storage of the data that is being imputed into the system and accessed. Then, of course, there's a messaging service. So you can think of your Facebook Messenger or the Instagram message feature, or your WhatsApp, which is basically a messaging app. So there could be a messaging service as well within the system. And all of these, they are not built together, they are built loosely coupled, but all of them are communicating and exchanging information to render the service you need. Now, moving on from here, if you have questions here, please let me know before I move on. Okay, you've heard what I just said before. Let me know in the comments. All right, Paula, go ahead, please.
Hi. Sorry, I had a question. I missed something you said. You said different services can be built with different programming language, but you mentioned what ties them together. I missed that part.
I mentioned what?
What ties them together? I missed
Oh,
that part.
okay, what ties them together is basically the data you need to access. So imagine you're a user, right? You've logged in. Now, after you've logged in, what happens? You are supposed to be shown your dashboard. And on the dashboard, there's some insights from analytics. You can see the number of your orders, the number of your inventory. You can see charts and all of that. There's a data analytics service in charge of that. You don't just get to see charts, right? So what happens? Your client, that is you, your browser or your phone, mobile app, makes a request via a route. So you can see api.product.com/users or /v1/users if the API is versioned, if you have different versions of the APIs. This is why I said you should go and watch that video on APIs. There's also what we call API versioning, meaning there's version 1, there could be version 2, 3, depending on what customers feel comfortable to, work with. You can version your APIs. It's best practices. So v2/users/insights, different routes or what we call endpoints. I know you would have heard endpoints. So there's a particular endpoint that's going to make a request to show the charts or the insights on your dashboard that you get to see. There's an API call responsible for the picture in your, what's it called now? There could be an API responsible for your user information that retrieves your name, your email, your profile picture, your other details and all of that. There could be an API that is making calls for that particular information. So all of these endpoints start pulling information that you are seeing on your dashboard. So that is what I mean by they are coming together to make things happen. So and the way they do that, like I mentioned earlier, they make these calls via a protocol called HTTP, which is why even if you enter the API call in the browser, if you find a way to authenticate via the browser, you can retrieve that information, which is why you don't even need a browser to access certain information. If you use Postman, which is used to test APIs, you can do the same thing you can do in your browser with Postman if you are technical to that extent. So I hope I've not confused you further, but the essence of the answer I just gave is that APIs communicate via the protocol called HTTP, and they access information through what we call endpoints that make certain requests for certain information or data to be sent back to them. All you need is data. You don't need the programming language. So whatever programming language was used to develop the file compression service or the authentication service or the messaging service doesn't really matter as long as you are getting the right data back. Does it make sense now, Paula?
Yes, it does. Thank you.
Awesome. Yeah. Any other question from anybody? Okay. So we'll move on. Before we now fully understand what microservices is about, it's very important we look at why what monolith is basically. So
Hi today.
yes.
Sorry to cut you. There's a question in the chat
Okay.
from someone. But I don't know if you want to go into your class and take the questions at the end of the session, or you want to continue like this.
I think I'll take this after the class, after the main session.
All right, no problem.
You can help me collate the questions. I will appreciate it.
That's fine, no problem.
Yeah. So, but please continue dropping the questions. It doesn't stop you from doing that. And if you want to raise your hand or have something to say, still do that, please. So monolith applications. What we mean by monolith is all of your services are built into a single system, right? All of your services are built into a single system. And apologies, I made a mistake here. So what you have here with actually this way. Control C, Control V. Apologies for that. Control X. Yeah. Oh, that made that mistake. Sorry about that. So this is the definition for microservices and not for monolith. But like I was saying earlier, the essence of monolith applications, right, is for you. I mean, is for systems where you use monolith, especially where you don't have a lot of services making calls to each other, and maybe you are just starting, you are just building a product, you don't have much clarity yet, or you don't have much needs or requirements, so you can get away with a lot of things if you go the monolithic route. There are products you use today that probably are still using the monolithic approach, and so it's not a bad approach. Don't think it's a bad approach. So it's basically a single software application that serves many functions. So if you take it, let's use Uber or any other ride-hailing platform as an example. There's ride management that manages your ride all through while your ride is in progress. There's location management that tries to locate the driver and the user or the passenger and manage that entire process. There's the user profile, there's payments, there's rating, there's safety. So if your ride has stopped for like 10 minutes, that notifies you that your ride has stopped for 10 minutes. All of this in a monolith system that is the same code base managing all of these services together. It's possible. And all of them are, reporting or routing to the same database. It's very possible. So you can, this is Paula, this is what I meant by endpoints. You can see API/v1/ride, or API/v1/payments or /rating. So your client, that is your phone or your laptop or your browser, makes requests to these routes, and these routes return data from the database to you, the user, which is why you see the information you see on your phone, on your laptops, on your browsers, and all of that, right? Now, so imagine that system. This is what a monolithic application looks like, right? Now, consider this, or look at this microservice, where you have the client, in front of a gateway. Let's call this an API gateway that now goes to these different services to make requests on your behalf to get the data you need back to you. So you can see the payment service could have its own database or be linked to the same database that ride management is linked to. There's a possibility, and for some reasons, your technical requirement might be that you need to separate the database. So there could be different needs based on your requirements, but all of them are single services on their own. And they could have built location management with Python and built user profile with PHP or JavaScript, and built rating system with Node.js, and built payments with Java, but as long as the data is being sent back and is consistent based on the specification, all is well. So microservices basically split a large application like you have seen in monoliths. This is quite large. They have splitted it into set of small independent distributed applications that even systems outside of, say, for example, Uber, can make calls to those services and get information back. So for instance, I'm building a product that leverages a customer's ride history to make certain decisions. All I just need is for Uber to expose their API for ride management to me, and I can call it and get the information I need concerning that user. That way, Uber is not exposing their payment system to me, not exposing their location management system to me. All I just can access is everything relating to ride management. That's all. Right? So this is a microservice architecture. Could be more complex than this, and by complex I don't mean hard, but have different other moving parts. But at least this gives us an idea of what we mean by microservice. If you have questions, please continue to drop them. If you prefer to talk or speak, please do that as well. Now let us examine the pros and cons of microservice, right? For microservices, the advantages are much, right? And I mean, monolith, of course, has several advantages as well. And one of the advantages of microservices is the availability and reliability. Because they are independent and loosely coupled, there is no single point of failure in the microservice-based architecture. So the architecture basically improves the availability and reliability of systems or services rather that you are offering to clients. So what that means is, maybe I don't need to order a ride at the moment. I just want to make a reference back to a certain ride I took 2 weeks ago. Maybe I want to get the time I started my ride and the time I got there. Maybe I'm having an argument with a friend that I got there before you. I can go and check my ride history. Now imagine a monolith application. I would have to, if their system is down for some reasons, I may not be able to do anything. I may not be able to sign in. I may not be able to retrieve my ride. I may not be able to order ride. Everything may be down altogether until they find where the bug is and fix it. But in a microservice architecture, I just want to get my ride details. It's not like I want to make payments. As long as the route responsible for ride hailing or ride management is fine, I can still retrieve the ride details. All I cannot just do is order at the moment, but every other function of the application is working. That is one of the benefits of microservice, right? Scalability. Each service can be scaled independently, right? Because different services have different traffic requirements. The architecture also utilizes the computing resources efficiently. So you don't get to have a large compute capacity and then you are not using it to the maximum and then you're having to pay for it every month. But with microservices, you can scale down resources for services based on their traffic. So imagine it's peak season for Uber. And they have to, let's not use Uber, let's use a Nigerian product. Imagine PiggyVest. I am assuming PiggyVest users will withdraw more in December because they want to do dirty December or they need to just make the festive season a good one for themselves. So they've started saving since January and now they want to break the bank, the piggy bank rather. So what happens? You start seeing a lot of calls being made to that particular service responsible for helping customers to open their locked savings, basically. And what happens? There's a huge traffic in December. What happens is if PiggyVest is probably going the monolithic route, they may not be able to serve those customers efficiently unless they increase the compute resource, which would then mean that they're wasting money because maybe I don't know the services that PiggyVest uses, but let's imagine they use rating. They have a rating system or a rating service. Maybe the rating service is not needed during that period. But again, you've increased the compute resource for everything. And that way, rating is not using that amount of resources. What happens? You're probably wasting money. But because rating is a service on its own, it doesn't scale up because there's not much traffic coming to it. The only thing that scales up is that service responsible for helping people unlock their bank savings. Their bank savings, basically. So that way you might see a huge spike for the unlock service. Let's call it unlock service. So you may see a huge spike in traffic for that particular resource, and that will result in a scale up of the resources that were that's responsible for that service. And that's all you need to scale up. You don't need to scale up the entire system. So that's also one of the benefits of microservice. So separation of concerns, like I mentioned earlier, let's make a reference back to it. So I just need the right management. Payments may be having an issue at the moment, but it doesn't stop Uber from still working. Uber is working. I can't just make payments yet, right? But they will fix it. So they don't need to start looking at, if it's monolith, they will start having to look at the entire system. Where is the bug? The bug may not even be in payment. It may be in safety that is now affecting payments, right? But with microservice, they know where the fault is. There's fault isolation. It's also one of the advantages, as you can see here. So with separation of concerns, is clear between the different services which may be having a problem. Each service is responsible for a particular functionality, and then the services can be divided into different things, and ownership can even be separated. So you have teams that are responsible for payments, you have teams that are responsible for location management, it just makes things easier. So that's why you could see in a product team or in a startup, you have different teams handling different aspects of the product. All you are just seeing is the product is working. You don't know what is happening behind the scenes. So this is one of the things that may be happening behind the scenes. They might have different teams for different microservices or services within their product stack. basically. Developer velocity and productivity, it means that because each team is owning a set of microservices, features can now be developed and deployed easily. So I won't have to depend on another team before I can deploy my own features. And then there won't be large build times because it's monolith. Building and deploying may take a while, but with microservices, each team is responsible for their own building and deployment. And product development seems faster and are more agile that way. And developers can then become experts on the code they own, and they can easily contribute to the future. So I don't have to know whatever is going on with ride management. If all I'm concerned about is payments, right? I become an expert in payments and I can make anything happen there. Or like a monolith, I may have to understand the entire code base before I can make a change, right? Also, multiple technology stacks. Each service can be implemented in a different language, right? Unlike a monolith, we are not constrained to the use of a single language for development. If I'm building in Python, in monolith, I have to build in Python all through, right? But with microservices, we can build in different languages, and it provides a lot of flexibility to the developers to experiment with different languages and choose the right stack, basically. So we've talked about fault isolation. Let's just look at the cons of microservice. The costs as well, it could be a challenge. A single monolithic application can be broken down into thousands of microservices, right? As the product matures and as the traffic also increases. What that means is that the associated maintenance costs also proportionately increase. So that's one of the cons of a microservice. Also, there's complexity, right? Because a feature encompasses multiple microservices. So in order to introduce a new change, you might have to modify the code base for multiple services, and it will require coordination between multiple teams or knowledge of the code base owned by different teams. Then debugging and troubleshooting, even though it could be easier, you can know where the fault is, that the fault is with payments. It could become difficult actually to debug and troubleshoot issues since hundreds of services are involved. So for you to analyze, for example, let's say latency regression, this system is slow, I'm not getting the right response on time. You may have to navigate through multiple services, but with proper monitoring, you may not have a problem, right? So monitoring is key to microservices. That is one of the reasons why we have monitoring, so that you can identify and isolate faults faster. Then performance as well. So there's an inherent performance penalty with microservices because different systems are communicating with each other, and then this increases the latency. For example, I remember a time when I was working on a product earlier in my career, and I was using Docker to deploy. I was using Docker and we are deploying to ECS, that's Elastic Container Service by AWS. And I discovered that all the API calls are very slow. They are taking seconds to return a response. I didn't know what was happening. I thought the problem was with Nginx, which is the load balancer. At the point I thought the problem was with one of the other services. What did I do? I just integrated a monitoring tool called Neuralink. At the point I integrated Datadog. I used all of these services to try and trace which call is responsible for this. By the time I was done, I realized there's a particular package I didn't install for PHP XML. Immediately I installed that package, all my API calls were fast, right? That was the problem we had. I wouldn't know that if I didn't use those monitoring service. And I may not have had that problem if I didn't try to build microservices. Do you understand? Because I was building a monolith system where I might not need several Docker containers to communicate with each other. Could have been easier as well. We could have not had a problem with latency, right? So a single call can fan out to multiple services, and it can also impact the overall latency of the feature. What we mean by that is a single API call can make several other calls to different services. So imagine a user wants to pay. You may have to make a call to the ride management feature to get the price for that ride, and then also make a call to the user profile to know which driver, so that when they are reconciling at the end of the month, they know how much to pay which driver, all of those things. And then also make a call to location management feature to, so that when they are generating the receipts, they can know, they used to include the map of the ride from what point to one point. They can know which point to what point to, that could make generating a receipt after I've paid a long process. But of course, it's not faster. It's not slow on Uber. That's because the system is, very efficient. But then those can be some of the drawbacks, right? And if Uber doesn't have a very, very solid technical team, they may be having problems. Even solid technical teams have problems, not to talk of the ones that are not solid. So those can be some of the drawbacks of microservices, which is why if you are building with microservices in mind, you are going to have a lot of, technical depth in your team so that they understand the system, distributed systems very well, right? So in monolith is kind of like the reverse rather for microservices when you consider the pros and cons. So in monolith systems, there are simple interactions because you are building a single monolithic application. It is easier for developers to understand the modules and their interactions because almost all the developers will understand the code base, right? And then the operations are, are local and it doesn't involve multiple distributed services. So you can easily manage, but at a point it may get difficult to manage too. So as much as simple interactions are important and, they can be beneficial, it could be costly too at a point. With costs, the infrastructure costs to maintain applications are lower because if I'm building a monolithic application, I didn't have a problem. I don't have any business with Docker like I did in the instance I talked about. I wouldn't, even if I would need Docker, maybe just one Docker container to do everything I needed to do, right? So as the modules then call each other through, API calls, there's no additional network bandwidth consumed because everything is within one system. So you are not making call to one application that is somewhere else on another server, another one. So all of your systems, all of your processing or logic are within the same system, and you are not making too much network calls. And one of the reasons why there are a lot of infrastructure costs rather get high is because of bandwidth that your systems have used. That's one of the reasons why if you go to AWS today, you're going to see one of the factors for cost is the network bandwidth rather. So monolith applications may help you reduce that. It also helps you with ease of debugging and troubleshooting. So developers can easily identify the root cause of an issue by looking into the logs and operational metrics, right? And they can deal with a single system. And it also reduces the time to fix the issue. There's also performance issues. There's also performance benefits rather. And, there are no performance benefits because different modules, all of the different modules you have are residing in the same application on the same host. So there's no network call involved. And, I mentioned earlier, latency is very much lower that way. And this results in a highly, performance system or monoliths, basically. And the cons of this approach is availability and viability and reliability rather. And what that means is that a monolith can become a single point of failure. And if the monolith system goes down, it may result in a total downtime and impact all the users. A bug in one functionality can also cause the whole application to fail. And this can reduce the availability and reliability of your product or your monolithic application. Scalability would also be a challenge, and that's because the build times and deployment times are more. And this makes it more difficult to deploy simple features or bug fixes, because fast-growing organizations can't scale with this type of architecture. So if you are scaling fast, if you are growing fast, if your product is gaining traction, you may not be able to scale with a monolith system, which is why if you start with a monolith system, at a point, you may have to evolve into microservices. Separation of concerns is not something that is readily possible, because all the functionality is embedded within a single application. So I'm trying to say, please, can you help me the feedback that is coming, please? Thank you. So, like I was saying, separation of concerns is something that could be challenging. There's no clear separation of concerns. Every team contributes to the same code base, which is quite crazy, actually. And any revert that is done like this to mitigate a bug in a new release will block a critical feature from going live. So your manager may be breathing down your neck. Why is this feature not live? They didn't know that a particular member of the team has actually made a change that is blocking you guys from launching. So that's it. And then there's inefficient resource usage, because each module will have a different traffic requirements. For example, now we talked about ride hailing. Here. What you discover is that the ride management service or feature may receive 10 times more traffic as compared to user profile, like I mentioned earlier. So for you to meet this demand, you will need to deploy 10 application instances. Meanwhile, the user profile module is being underutilized, and then you are increasing your cost at the expense of that. So those are some of the drawbacks. So you have to choose your poison. So I'm sure someone will want to ask, why? I mean, should I choose between monolith or microservice? It's actually, there's no right answer, there's no wrong answer. You have to make a strategic choice, right? The choice depends on business needs and organizational goals. Today, the world is fast moving, so technology drives business growth in ways you can hardly keep track of. So companies must be agile and innovative to stay competitive, right? And then many software teams also operate in small cross-functional units. So each are getting to manage specific business functions. So that way, deployment is done with the concept of continuous integration and continuous deployment in mind, so that you can ship features quickly. So if you consider all of these factors, you will know the right decision to make. For example, I mean, let's imagine a startup. A startup benefits from monolithic application because it reduces complexity and cost. Because microservices can lead to over-engineering at an early stage, right? Your product, you don't even know if your product would be accepted by the market. So why are you wasting your time building a microservice when you can build a monolith to run concepts, to run experiments and then get feedback and validation, right? Now, if you consider the stage you are in, say you are still a startup, you may want to go monolith. If you are scaling, you can consider a well-structured monolith that you can scale if it's loosely coupled and testable, right? So it can still be a monolith, but you can make it such that you can still scale with it in some way. Because but as complexity grows, right, it may slow down your development time. Now, transitioning to microservices is something that it can be costly because you may need more hands, and it also requires careful planning. It should only be done if the benefits outweighs the effort and costs, right? So it's also ROI driven. So it's not necessarily a technical decision. At some point, it will become a business decision, right? So which is where it's very important that as a product manager, you have influence across all functions: business, products, technical, engineering, finance, support. You need all of these cross-functional units to be able to carry out your job. And I'm sure every other product manager that has come and discussed these topics with you on your learning moments, you would have understood this as well and have systems in place for you to learn skills or at least get better at those aspects of the aspects of product management. So I just have a few examples of what we've discussed so far in terms of microservices. So if you consider, we've used Dubai a lot as an example, but there's also Netflix, there's Airbnb, who have successfully adopted microservices for scalability and operational efficiency. Paystack has done that too in Nigeria. MoneyPoint has done that. Flutterwave has done that. There are several startups in Nigeria that are doing that as well. Now, let's talk about another interesting aspect, which is what we call service discovery. So one thing I don't want you to do is to be intimidated by these terminologies. As a matter of fact, when you're interacting with your engineers, if they use the term you don't understand, feel free to ask. Or if you are too shy to ask, once you're done with whatever you guys are discussing, go back and read up on that thing. But I would advise you to ask. And the reason is because no one knows it all, right? And in asking, you can even tell if this person knows what they are saying or not. So someone used the term KYC and you don't know the meaning of KYC. You ask them. They use the word they use the abbreviation PII. You don't know what PII means. Ask them. I've done that on calls, even with customers. My CEO does that. Where I currently work, where I used to work, my CEO does that. Not that he doesn't know the meaning, but there could be other people on that call who don't know the meaning. So you don't just throw language around or lingos or abbreviations. You need to speak in clear terms that people will understand. So please feel free to ask. It's not a crime, and don't be shy about it. No one knows it all. There are things in product management or concepts you probably know that someone else doesn't know as well. And it's your duty, if you know it very well, to explain to them. So don't be bogged down by these terms. You can read up on them. They are just concepts. You don't need to try them. You don't need to practice them. You can if you want, if you have the technical ability, but you just need to understand them enough to be able to explain to a 4-year-old. And if you can do that, trust me, whatever is happening in your product team, you can understand. So service discovery is a process, or better put, a concept, right? And it's a how, basically. It's how services automatically discover and connect to each other when you consider a microservice. We've left monolith now, we've forgotten monolith. So we are still dealing with microservices. So it's how services automatically discover and connect to each other, like I mentioned earlier. And if you consider a traditional monolithic application, all the components within the application are connected and they are all shipped together. But in a microservices architecture, services are often deployed in separate containers or virtual machines. You can also refer to servers as virtual machines. And these servers, they all have IP addresses and ports that can change due to scaling. Or maybe you have just one server running before, and now you have a lot of traffic. The server can scale to 10 other servers. All of them will not have the same IP. They will have different IPs and different ports, right? So what happens if you experience that? Your servers can change IP if the server fails and you may need to restart, especially if you don't have static IP addresses. Or you made a new deployment, the server needs to what's the word now? The server needs to rerun and then, probably terminate the old instance and create a new one. If that happens, you're probably going to lose that IP address, because having, what's it called now? Static IP addresses, as the word implies, static means IP addresses that do not change. If you have static IP addresses, it's not free. It's not free on any of the cloud infrastructures. You have to pay for them, right? But I mean, that's another conversation. There are cases where you require static IP addresses. There are cases where you require dynamic IP addresses. It doesn't really matter to this context. But what I'm trying to say is your IP addresses can change for different reasons. Maybe because of a new deployment, because of failures and all of that. So service discovery basically provides a system or a mechanism to abstract away these dynamic locations, because your IP address is a location. It's an address, like it's stated in the name. So it allows services to discover and communicate with each other without hard coding addresses. So imagine your IP address changes. What's going to happen? That means a system that depends on that IP address is going to fail. Can't work again because it cannot communicate with that server again because that IP address does not exist again. So you can think of service discovery as a dynamic phone book for the services. That is a phone book that even if the phone number changes, the service is still working. It's as simple as that. And an important component to that concept or process is service registry. It is a key part of service discovery. And a service registry is basically a central database that stores all the information about the available service. So you have your right management service. It stores the information about the service and their instances, right? It stores, if it scales up to 15 other instances to accommodate traffic, it stores it. So that when the client is making calls to access that particular service, all of those instances can be easily accessed via the load balancer. So it basically maintains a real-time view of the service landscape. So if you have 10 microservices, right, with about 50 instances in total, because one of the microservices might have 10 instances, another one might have 15, another one might have 2, another one might have 4. So if you combine all the instances that have been spinned up to accommodate the current load, maybe they are 50. The service registry stores all of those information and makes it available in real time, so that any client that is making a call to access those services can pick any of those instances to retrieve information from. So service registers or registry, services register themselves within this service registry, right? So that those information can be readily available. And then they then periodically send you can call them heartbeats or pulse, to indicate that they are still healthy. That is why you have status checks. You have systems that have status checks, because those status checks are basically HTTP requests to that service to confirm there's still a 200 response that is being gotten from that system or that service. So as long as that particular status is still being returned, that service is still up. Immediately it fails and another one is pinned up, the service registry gets it again. The service registers itself in the service registry, and all the IP and ports are available for the client to be able to access. So that's basically service registry. Imagine it. So when you consider holistically what service discovery is about, remember a dynamic phone book, that you don't have the problem of I lost his phone number or I lost their phone number, so I can't contact them again. No, their phone number is their phone number, but you have a way of being able to access their phone number even if it changes. It's as simple as that. Now, there are two types of service discovery that I know of. I don't know if there are many, but there are two types I've read on, I've interacted with. There's the client side service discovery, and this is originating from the client that is making the request, sort of. What that means is that when you are using a client side service discovery or client side discovery, the client is responsible for determining the network locations of available services, the instances, and is also responsible for load balancing requests across them, right? So it queries a service. It queries this service registry you can see here for the information it needs. Don't forget this service registry is the database of available service instances. So the client queries this service registry Then the same client then uses a load balancing algorithm to select one of the available service instances to make a request to. So you could use round robin. There are different load balancing algorithms, but we won't get there now. I mean, it's not important to you because you're not the one doing that. But at least you know that there are load balancing algorithms that helps to route requests. So basically, what the client does is, what the client side service discovery does is it's responsible for making a request to the service registry so that it can locate a service rather to route a request to. So once a service is located or available, the registry aware client will now make a request so that a response can be received. That is basically what client-side service discovery is. So you can see an explanation here. Client is responsible for first querying the service registry and then fetching the details of the available instances. Then the client is responsible for load balancing their requests across multiple instances of the downstream service. These are the downstream services. In this pattern, the client has to do all the heavy lifting, as you can tell. But with server-side service discovery, it's quite different, right? And with server-side service discovery, the client makes a request to a service via a load balancer. So there's a load balancer in place now. Now the load balancer queries the service discovery. You may be asking what a load balancer is. Sorry, I didn't explain. So a load balancer does different things, but basically what it does is it tries to ensure that it balances loads across a system. So if you have 15 servers serving your customers, it doesn't put all the load on just one server. It tries to balance requests across the 15 servers so that it is optimal. That is basically the word of a load balancer. It also helps to route traffic, right? It also helps to route traffic. So if your traffic is meant to go to server B, you don't have a problem. The load balancer will help you send it to server B. That's basically, so it balances requests across servers and it also routes traffic as well. So the load balancer queries the service registry. As you can see, the arrow is going to the service registry, and then the service registry, the load balancer then routes each of these requests that has come to it. It then routes it to the services or the service instances. So the client makes a request, then the load balancer sends the request to the service registry to check available systems or instances, and then it routes the traffic to those instances, and then the customer or the client rather gets a response back. So that's simply, so in client-side service service discovery, the client is responsible for handling everything, including load balancing. But here, there's now a load balancer, a standalone load balancer that is helping, right, to make those requests and then route it back. So let's look at an example. If you are familiar with AWS, you know there's a certain convention they used to name all the services on AWS. So you must have heard of ELB before, or AWS Elastic Load Balancer. That's ELB. It's an example of a server-side discovery router, right? So the ELB is commonly used to balance, load balance external traffic. So traffic is coming from 1 million users. That's across the internet, right? So you can also use it to load balance traffic that is also internal, that is traffic within your virtual private cloud. So imagine your cluster of services, right? You can also use the ELB to route traffic within that VPC, within that virtual private cloud. So a client can make a request via the ELB, via the load balancer. Then the load balancer can, can balance the traffic among a set of registered servers, or what we call EC2 instances, Elastic Compute Cloud. So please don't be worried about the terms. It's not as important as understanding the concept. So at this point, I don't know if anyone has questions or they want to talk about something or they want to highlight something before I move on to other aspects of the of the session. This is 8:11 already. We are 1 hour in already. Uh okay. Yeah, let's move on.
We have like someone's hand raised, but I think we have like two questions in the chat. Mistakenly logged off, so I can't actually see the questions.
I
So
think I
possibly
can.
you can answer. Yeah, you can see them. Okay, maybe we can answer those questions, and we can take like those people whose hands are raised. Favor, do you want to like control this?
I can't see those whose hands are raised unless I go to the call. So please help
Yeah,
me.
I can always help you with that.
Yeah,
Favor,
please.
can you hear me? Um. Okay.
Yes, I can hear you. So,
I said
so quickly before
okay.
you go ahead, before the
Okay.
questions come in,
Yeah.
I think that we have about 18 minutes left on this call, and I
Okay.
think we have a lot more slides to still go, and I think we have a lot of questions still coming. I sense some people are going to go and meet their developers and start talking about something from tomorrow. But yeah, I think we still have a lot of things to cover and a lot of things to go. So
Okay, actually we have two more slides to go before we dive into my browser. So
okay,
I can quickly round up the slides and then we can move on to questions and then a quick case study.
okay. So let's quickly see how we can do the slides in 5 minutes. Move on
All
to
right.
questions as quick as possible, and we wrap up from there.
Yeah. So the this view you are looking at, we have REST versus GraphQL. You may be wondering what is REST, what is GraphQL. In the video I made reference to earlier, I touched on REST, but it's not just REST, it's RESTful API. It's a specification for for APIs. And the full meaning is representational state transfer. So you are building APIs that is RESTful, and it's a popular architectural style, for requests and responses. It can serve as a good example of synchronous communication, right? And what is a synchronous communication? A communication where the 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 request or the whichever service is making the request has to wait for a response to be sent back. That's a synchronous communication. It's based on HTTP, of course, and then it makes use of verbs like get, post, put, delete. I know you would have heard them before. So that's basically a REST API. And in this pattern of communication, the caller, like I mentioned earlier, it has to wait for a response from the server. And then for GraphQL, it's a bit different. It's a query language for the API, basically. There's only one endpoint in GraphQL, unlike in REST. Let me go back to a few slides. You can see different endpoints. If it is a GraphQL, it should just be v1 slash something. And that's all. You now have to be making calls per the kind of resource you need. So because with RESTful API, it returns all the data. So if you want to get user information here in this system, if you want to get payment information, maybe what you need is the date the payment was made. It will return all the details about that particular payment. You will now have to pick the date of the payment there. But with GraphQL, once you make a call to that one endpoint, you can pick out the resource you want in that endpoint without having to expose all the information in the endpoint, right? So that's the sort of simple difference between the two, but they have a lot of similarities. So it's developed as an efficient alternative to REST, because with regular REST APIs, you can hit an endpoint, and then the endpoint will, the API will return an object with a lot of other data in it, like I mentioned. And instead of that happening, with GraphQL, you can write a query to request exactly the data that you want. So it just makes things easier for you, and then you don't have to deal with a lot of objects in your response. So some of the similarities are that both REST and GraphQL, they implement several common API architectural principles. And an example is they are both stateless. So the server does not save response history between requests. It doesn't save them. And then they both use client server model. So there's a client and a server. And so requests from a single client result in replies from a single server. And they are both HTTP based as well. So those are some of the similarities. They are also resource based design. And what that means is that they both design their data interchange around resources. Like, I've been making reference to resource a lot. And the resource is any data, or objects that the client can access and manipulate through the API. So let's imagine a social media API where a user can create and manage posts. In a resource-based API, you would consider that post as a resource, and it has its own unique identifier. For example, API / v1 / post / the ID of that post, because on Twitter, if you make a Twitter, if you tweet, that tweet has an ID, a unique ID to it. So /tweet / the ID, maybe it is 12 AJF kini the string can go on. So if I make a call to that endpoint to retrieve that post and its details, that post is a resource on its own, and it has a set of operations that you have to carry out to retrieve that particular request, or queries in the case of GraphQL. Then both are involved in data exchange. They support the same or similar data formats, which is JSON. And JSON happens to be the most popular exchange format, data exchange format. JSON is basically JavaScript. What's it called again? How did these things skip my mind? Who knows the full meaning of JSON, please? JavaScript object notation. Yeah, that's what it's called. Also, the language and database neutrality. They are language and database agnostic. So whether you use MongoDB as your database or you use the MySQL, whatever the database you are using, is both GraphQL and the REST API, they work with any database structure and any programming language, right? And then it makes them highly interoperable with any application. You can use them interchangeably or with any application, and it just makes there interesting ways to use them. Now let's go to messaging quickly. This is the last slide I have before we dive into my browser. With messaging is a widely used is a widely used concept in microservice architecture, and it follows the asynchronous protocol. Remember, REST is synchronous. Messaging is asynchronous. And with this pattern, what happens is that a service can send a message without waiting for a response. It can continue doing what it is doing while that response can come later. And one or more services can then go ahead and process the message asynchronously. You can work asynchronously. Maybe you have something to discuss with a team member. Synchronous will mean that both of you will have to pause everything you are doing, get on a Zoom call, and discuss. Asynchronous communication means you guys can chat. Maybe I'm working on something now. I can respond to your chat in 30 minutes, and you can also pick up the chat tomorrow morning. We are still working. We are not just working synchronously. We are working asynchronously. So if you think of it that way, you would understand when your developer is talking, we need to make this asynchronous. It means, well, this can happen and then something else can continue happening. That's basically what it means. So basically, we've not even talked about messaging. I've continued to ramble on. Sorry. So imagine this chart, this view you can see here. There's a producer, that's the person, or that's the resource, or whoever is making a request, right? And then the message is sent to a broker, which then goes ahead, to send the right response out to whoever is meant to consume the message. Now there are advantages of asynchronous messaging, but we won't look into that right now because of time. But we'll just explore the concept of pop sub pattern and queue based pattern. So in messaging, you have pop sub, which means publisher subscriber pattern, and then there's queue based pattern. So the publisher subscriber pattern is useful when you have a service that needs to broadcast information to a significant number of customers. So what happens is that the message broker or the message queuing service now picks the message you have sent, returns a response to you that says maybe success or processing, processing, and then goes ahead to start sending the message to these subscribers, right? So you can go on and continue doing any other thing, and as each message delivers successfully or it fails for each subscriber, you can get the response back later. So you don't have to wait for all the messages to be sent before you can move on. You can move on and then wait for response and then expect response later. That is pops up pattern. So there's a publisher, there's a subscriber, and there's a message queuing service or broker in between that manages whatever has been sent. Then there's queue-based pattern, where you have where it's useful for any application that uses services that are subject to overloading. So a sender posts a message, for example, to a queue containing the data required by the the receiver or the consumer or the subscriber. Then the queue acts as a buffer, storing the message until it is retrieved by the receiver, right? So the receiver then retrieves the messages from the queue and then processes it at their own pace. And you can use this pattern for applications that use services that are subject to overloading, right? So you have a service that is subject to overloading. All you just do is you have a queuing service that service can call at any point in time to retrieve the message from, without having to overload the producer, right? Without having to overload the producer. So that's basically what these patterns are in messaging. Now, to the browser, you can start asking your questions. Maybe your question we even inform the what I'll share in this next phase. How many minutes do we have left, Favor?
Yes, today we have exactly 7 minutes left, and I don't know if we have enough time to
All right,
show everything we need to. But as people are asking the questions, and you are getting ready to show your browser, I don't know if you'll be able to do that. We have I'm sure everybody's like very, very intrigued, and okay, a lot of things are coming to you guys. I've shared a couple of links in the chat box. First is today's API. The last on the list is today's API session on YouTube that you can catch up with, which is like a prelude to this particular session and will help a lot. And at Treford, we always ensure we get feedback on how our sessions are. So you can go to that link to share feedback about how this session has been. And also, we have a program also upcoming, which is about API product management, where we'll be talking about APIs in depth. Like this, today is also a facilitator and has about 2 sessions in this program, and to be starting in June. So if you're very much interested in that, it's not yet publicly out. It's going to be starting in June. You guys are the first community we're sharing it with. If you're very interested in that, you can just fill that form so we get across to you as the first set of people who will be taking advantage of that particular program. The seats are very limited. So if you're interested in that, just fill that form. And yes, if you have any questions, we have just exactly 5 minutes. Any questions you can take in 5 minutes. I know there's some.
So I think we should just. Hi, Fiba, can you hear me? So I think
Yeah.
we can just like answer the previous questions in the chat, right?
Yeah.
So I today can run through that. So for the practical session, after you're looking at probably bringing you back for us like a question for another time where we can just do like full practicals on everything you have to do, like the case studies and stuff like that. So like that would take like an entire session another time. So you can always like share your ideas, but we can just go ahead and answer the question in 5 minutes, all the questions we have in 5 minutes. Then we take the practicals in the next session.
All right. Awesome. So I think the first question here that I should answer, I don't see much, but I think Joseph, yeah, Joseph, you're asking if different microservices share the same database. Yes, they can, and they can also not. It depends on what your design pattern is or what the essence, I mean, what kind of data what kind of data has been stored, right? So if you are using if you build an application that is in real that sends real-time data back to your database, maybe at 2 minute intervals, you wouldn't need a SQL database or MySQL, a relational database with rows and columns. You may not need it. You may be needing something like MongoDB that stores data in JSON format. So that means for some aspects of your product, you may be using MySQL, and then for some other aspects, you may be using MongoDB. But it doesn't mean that you can't use a single database for your microservices. It's possible. And in some instances, it may not be the best way to go for you. It depends. So the situation or the context will determine what approach you are taking. I hope that's clear. If you get that, please, you can leave a thumbs up so that I can move on to Judith. Judith, I think your question has been answered. Please confirm that by also giving a thumbs up, or you can, push back and let me know. So that's about the use case for a product. Who gave a thumbs up now? I barely saw that.
Yes, my question has been answered.
Okay, that's Judith, right?
Yes, that's it.
Awesome. So, Somi, will you advise microservice should be used or adopted when building in fintech products? Definitely. Definitely. Yeah, I would advise that. And I don't think anybody is doing fintech today that is not considering that approach, already doing it. So it makes life easier for you because you don't want to rely on a single or monolith application for all of your services. If something happens, everything goes down, right? So yes. And I think as an advice, I would say that you guys can relate with your, developers or engineers after now, and they can even explain these concepts further to you because they deal with it every day. It's okay for you to know how the architecture of your product works. And if they are building right, I believe they are also documenting the process. So you can ask, and then they can even share the resources with you so that you can better understand. It's not out of place to ask. All right. Can you have the slides? Yeah, Favor will get back to you. It's restful, Jason. Deborah, like I mentioned, you don't need to worry yourself about the terminologies. You'll get them in due time. You don't build, you're not an engineer. So it's not a crime if you don't know them, but it just helps you and makes work easier on the long run. And it's also a challenge. You love challenges, you may want to understand them. So you asked the question, I don't understand ADME. Okay, someone raised their.
Yeah, no, I think no, that was when you were asking the question about Jason and you answered it yourself.
Okay.
Yeah, so,
sorry, that skipped me for a bit.
Yeah.
yeah.
Yeah, so I think we've come to the end of the session for now. So I think we will see to rescheduling. We'll see to rescheduling where you can have like a practical session with everyone here, share case studies and show the browser how all this thing works in a practical way. It's exactly 8:30. Thank you very much to everyone. Once again, I'll just encourage that you share feedback with us. We like to always have feedback on our sessions. Right? So click on the Slido link in the chat. I believe Esther will share the link as well on the community page, so you can always click on it. But you can just click on the Slido link in the chat, share feedback with us. Click on the link to catch up on the YouTube video on API. It's free, and let us know if you like to join the API Products Management Program. Thank you all. Over to you.
Yes. Thank you very much, Favor. And you also like check out record and ensure that you register for some of the interesting things they have coming up. And like I said again, this is PIP's webinar series that happens every second and last Thursday of every month. And like it's always very packed. So I'm sure you learned a lot today. So we hope to see you again second Thursday in the month of April. I will be learning about documentations and also still going into technicalities, AIs and stuff like that. So yeah, and we also have other programs. We have like our GMS group method session and the um interview prep session that happens Tuesdays interchangeably, and we do look forward to having you here. So thank you, Trefford. Today's session was hosted by Trefford, and thank you, Ayo, today for coming on board. We really enjoyed our time with you, and do enjoy the rest of your evening, everyone. Bye for now. Thank you.